Hello everyone. My name is Vivek. I am a software developer. I make videos about containers, Kubernetes, Go as a programming language, distributed systems, and sometimes about software engineering in general. So, if you have been liking the kinds of videos that I make, you should consider subscribing to the channel and you should follow me on Twitter as well. In this particular video, we are going to continue writing the Kubernetes operator that we have been writing in some of the previous videos, and this is going to be the final video in that series. So the Kubernetes operator that we have been writing was this operator named cluster with K, and that operator, once deployed on a Kubernetes cluster, should provision a Kubernetes cluster on DigitalOcean respective to a cluster resource. So we have done a lot of things already. For example, we have introduced a new type named cluster. We have generated all the client set deep copy functions, informers, client sets, etc. And we were also able to write the code to handle addition and deletion of these cluster resources. So all these things are already done. I will link the playlist down somewhere so that you can watch those videos. In this particular video, we are going to so to test this particular operator, we have been deploying it in the local machine on the host itself. But in this particular video, we are going to look into how we can deploy this operator inside a Kubernetes cluster as a pod. So this is what we are going to look into as part of this video. So we know that to deploy any application on a Kubernetes cluster, first of all, we will have to create, or we will have to containerize that application. So we already have this entire application set up with us, and the first step would be to containerize this. To containerize this, we are going to use Docker, and when we want to containerize an application using Docker, we will have to create a Docker file. So let's just go ahead and quickly try to create a Docker file now. uh, the I'm just going to write very simple Docker file, but obviously there might be a lot of other better ways to write this Docker file for the exact same purpose. But yeah, right now we are not focusing in that. So what we are going to do is we are just going to get let's say Alpine, and once we have Alpine, and we have already built the cluster binary, so all we have to do is we just have to copy this binary onto this image. So we are going to copy cluster to user local bin, and once we have copied this binary to user local bin, we can specify uh, entry point, and entry point expects an executable. So in our case, the executable is cluster, because if you remember in the previous videos, once we have built the application, we just ran the binary to run the application. So that's what we are going to do. So we don't exactly have to specify entire path, because I'm assuming that this particular path is set as path environment variable in Alpine image. So this should work. But before actually building the image, what I would like to highlight is, if we go here and try to look into this particular source code, and if you see here, we are trying to create the config from the kubeconfig file that is present at this particular location, or we will have to specify kubeconfig file using this flag. But this works fine if we are running the application on host machine. But if you are running the same application inside a pod, in that case we are not going to have a kubeconfig file at this particular location. So this particular code block is not going to work, because as I said, kubeconfig file is not present, will not be present inside a pod of Kubernetes cluster. So in that case, to handle that, we will have to use InClusterConfig API, and InClusterConfig API eventually uses the secret account that gets mounted to any pod, or to all of the pods of Kubernetes cluster. If you are not very sure about InClusterConfig, I have already talked about this in some of the previous videos. I will link that down as well. So if we were not able to create config, it simply means that we are not running somewhere where kubeconfig file is present. We are running somewhere where there is no kubeconfig file, and presumably inside a pod. So what we are going to say here is building config from flags failed trying to build in cluster config, and then we are going to say config :error equals to, we are going to use rest package for this, rest from client go, and rest dot in cluster config. So it simply uses the service account that is mounted inside a pod, because we are going to run this application inside a pod. So if error is not equals to nil, in that case log.printf error building in cluster config, and error is going to be this. So now things should work as expected, and we should build this entire application. So let's just go ahead and try to do that. So first of all, run go build. Now again, we can obviously change this Docker file to run go build first and then copy the binary to this particular location, but just to simplify the things, I'm going to do this. So I'm just running go build, and this is going to create a binary, and once that binary is created, we are going to run docker build to create an image out of this Docker file. So this has been updated, and now all we have to do is docker build, tag the image. So let's tag that to be Vivek saying ggits cluster : 0.1.0, and we will have to pass the context as well. So yeah, now this should work as expected, and all we have to do is we have to push this to our Docker hub. So let's quickly do that. So docker push and push the image. Once this is pushed, we can go ahead and try to create a deployment that is going to run this particular image. But meanwhile, we can try to run this image just to see if things are working fine or not. So docker run rm it, let's see. Okay, so yeah, I mean, things are working as expected. Kubeconfig file was not found. We used InClusterConfig, and it says these things are not defined, and the reason is we are running as a container, not inside a pod. So yeah, we are good here. Now that we have pushed the image as well, what we have to do is we have to create a deployment manifest to run this particular application. So let's just go ahead and try to do that. So kubectl create deployment. Let's name it cluster, and image is going to be the image that we just built, and we don't want to create it. We want to generate the manifest. So deploy.yaml, and we want to store it so inside manifests. Let's create another directory. So mkdir, and let's name it install. All right, here we go. So now that we have this deployment.yaml, what we can do is we can just apply this deployment to create the pod using this image that we just built. So let's just go ahead and try to do that. So install deploy.yaml. This is eventually going to create a deployment with this particular image that we have specified. Okay, so a deployment has been created and the pod is being created as well. Let's wait for this pod to be up and running, and then what we would do is we would create a cluster CRD and a cluster resource to actually get the cluster created on DigitalOcean. So let's quickly go ahead and try to have a look into one of the cluster instances. So this is an example of a cluster instance, and we obviously specify token secret, so we will have to create this token secret as well. So let's just go ahead and try to do that. So create secret, and this is my DigitalOcean token, so named do secret and in default namespace. So do secret has been created. Now we will also have to create the CRD. So let's go ahead and try to create that as well. So create -f and then cluster clusters.yaml. This creates cluster CRD. So custom resource definition clusters created. Now as soon as this pod gets into running state, we are going to create one cluster resource, and respective Kubernetes clusters should be created on DigitalOcean. Okay, so now that we have pod up and running, let's see the logs of the pod, and here we go. So this is the problem. I would say this is the most important part of this particular video. So if you see here, it simply says system service account default cannot list resources clusters in API group this. It simply means that our application that we just deployed is running as default service account, and that default service account cannot list clusters. So yeah, I mean, I already have a video on service accounts. I will link that as well. But if we don't specify any service account in the deployment manifest, so if we look at deployment manifest, and if we don't specify any service account here, the application that we have packaged is going to run as default service account. And as we see here, it simply says that default service account doesn't have permissions to list the cluster's resources. Now to resolve that, what we will have to do is we will have to create another service account. We should not use default service account, and once we have created that service account, we will have to make sure that that service account is able to do these things that are mentioned here. And once that service account is allowed to do those things, we will have to specify that service account in this deployment manifest. So that is what we have to do. Now to do that, we have to create, first of all, as I said, we have to create service account, and then to allow that service account to do certain things, we will have to create cluster rule bindings and cluster rules. So again, this is very much related to RBAC. I also have a video about RBAC, so I will link that down as well. So let's just go ahead and try to create a service account named, let's say, cluster SA, and that's pretty much it. So client -o YAML and then sa.yaml. So we are not actually creating service account, but we are just generating the manifest, and this should go in install sa.yaml. Now that we have service account.yaml, we will have to create cluster rule, and the reason is we our application is listening for cluster resources, sorry, this cluster resources on all the namespaces or in all the namespaces. So that is the reason it says we are not able to access these resources at the cluster scope. So that is the reason we will have to create cluster role and cluster role binding. So first of all, let's go ahead and try to create cluster role, and let's name it cluster role or cluster cluster role. And in cluster role we can specify what are all the permissions that we want to allow and on which particular resources. So the resource that we have, we know that is cluster, and the verbs that we want to allow is list and watch. So again, we don't want to create this resource. We want to first look at the manifest. So let's generate the manifest. So this is cluster role.yaml. Okay, so now that we have cluster role let's move it to install. Now that we have cluster role.yaml, we can see that this allows list and watch on clusters. And once we have that, so we have created service account, we have created cluster role, and to map these two things, we will have to create cluster role binding. So let's go ahead and try to do that as well. So cluster role binding, let's name it cluster role binding, and this is going to map those two things. So service account create cluster role binding, and this expects cluster role, and the cluster role that we have is this, and this also expects service account. All right, here we go. And the format of service account should be namespace and name. So we know that our service account is in default namespace, and name of our service account is cluster SA. And again, we want to create the manifest, and then let's save it in crp.yaml. We have not specified crp. All right, here we go. So we have move that to install. We have service account, we have cluster role binding, and we also have cluster role. Now let's just go ahead and try to specify this service account that we have here in deploy.yaml. So I actually remembered how do we do that. So for pod specification, this is pod specification. For pod.spec.service account name, we can specify the service account. Okay, now what we are going to do is let's go ahead and try to delete this. So okay, and let's go ahead and try to install everything once again. So kubectl create -f install, and this is going to deploy every manifest that is there inside install directory. So yeah, it has created cluster role binding, service account, and deployment. So get pods, we have the pod up and running. And now if we check logs of pod, if you see here, all the previous errors that we saw, all these errors have been resolved. They have disappeared. So now to actually test the things, let's just go ahead and try to actually create a cluster resource. So kubectl create -f, and we are going to specify the cluster manifest. So let's use cluster1, and as soon as I hit enter, okay, here we go. So if you see here, handle add was called, we have everything. But again, if you see here, it simply says that this particular service account, this is the same service account that we have specified in deploy.yaml, or our deployment, cannot get resources secrets. And if you remember, if you have watched previous videos, we need this because obviously we get the secret name from the cluster resource, but we actually have to query this particular secret so that we can get the token out of it. And that is the reason we have a logic where we query this particular secret, and that is what is failing here. So now we will have to allow this permission as well. And let's look into the other problems as well. So for example, it says other things, and it also says there is another problem, that is cannot get resource updating status of the cluster 0. So it simply means that we are trying to, again, if you remember, at one place in the code we are trying to update the status of the cluster resource, and it simply says that we were not able to update because we don't have permissions to, right? And the other thing is, it says cannot create resource events in API group core. So this is another problem. And yeah, so these are some of the problems that we have to solve now. So let's just go ahead and open the crb.yaml or cluster role.yaml, and in cluster role.yaml let's specify another rule, and in that another rule we are going to solve this particular problem, that is cannot create resource events. So API groups, and we know that events are from core, but that is mentioned here as well. Empty strings in group means core API group. So empty API group, and resources is going to be events, and verbs is going to be create. So now, but this particular rule is actually going to resolve this particular issue, but we have some other issues. One is update is not available. So for example, if we have, yeah, as I said, if you remember, we at one place we try to update the status of the cluster resource, so we will have to allow that permission as well. So let's go ahead and try to do that as well. So API groups, and group for cluster resources is this, and we have to specify resources. And here is I would say again one of the most important things. So when I introduced sub resources or status sub resources, we discussed that we have that status sub resource so that we can specify roles in such a way that we are just able to update the status sub resource and not the spec. So yeah, again, let me quickly go ahead and try to explain that. So this is what I think this is where we discussed about that. So for example, for any Kubernetes resource, almost every Kubernetes resource, we have type meta, object meta, spec, and status. And in case of CRDs, we have specified status to be sub resource, and the reason was the operator or the controller that is running, that is entertaining this particular resource, should not be able to update spec of the resource, but only be able to update the status of the resource. And this is the reason, because status is going to get another endpoint, and we are going in the API server, and we are going to specify, or we are going to allow updates to that sub resource endpoint only. And if our operator wants to update spec, the operator won't be able to, because ideally spec should be updated by users and status should be updated by controller. So yeah, I mean, we discussed about this when we discussed about status sub resources. So what we are going to do is, we are going to specify resources to be cluster slash status and obviously verbs is going to be update. So now what we have done is we have resolved this particular problem. And we also have to allow access to the secret resources, and this is a bit tricky part. This also depends on how do we want to do this. So for example, I don't think we should allow access to secrets from all the resources to your operator, because that is not what we actually want. We want our operator to access secrets from the namespace where the cluster resource is created. So let's just go ahead and try to create roles and role binding for secrets instead of cluster role binding. So create, and we are going to create role. Let's name it role or K role, and this is going to allow access to secret resources, and verb is going to be get. And again, let's just generate the manifest. So -o YAML, and let's name it cluster role.yaml. And once we have created this role, we will have to associate this particular role to the service account that we have created. So let's do that as well using role binding. So kubectl create role binding, let's name it k role binding, and this is again mapping between role and service account. So service account is going to be default cluster -sa, and role is going to be this particular role, and we want to create it in default name itself. So dry run, and let's name it k role binding.yaml. Alright, let's go ahead and try to have a look into these things. So again, I'm sorry about this. Let's move it to install. Yeah, so this is the role that allows get access on secrets, and we have mapped this role to our service account using this role binding. So this maps role k role to service account in default namespace. Now we have all these things. What I would like to do is let's delete everything again. So this is going to delete all the resources that we had created, and let's create everything once again. And here we go. So everything has been created. Now if we look at the logs of the pod, okay, it says okay, so if you see here, it simply says we tried to call the Kubernetes API, DigitalOcean API server. Again, this should not have been broken the pod itself. We have not handled the errors very correctly. This is not obviously production ready. We are just I'm just trying to show you how things are done. So this is nowhere near I would say production use. This should not have been broken the pod. But yeah, I mean the issue is it simply says that the version slug that we have used is invalid. So let's go ahead, and if you have watched other videos, we know that we figure out the version from the cluster resource that we create. So cluster 1, and this is where we have specified the version. To actually figure out the version, what we can do is we can query another endpoint. So let's go ahead and try to do that. So this is the endpoint that can be used to query all the versions, etc., that are present or that DigitalOcean supports. So if you look at the error, if you look at the response, it gets sizes and versions, and the version that we have is this one. So let's copy this over to here, and now what we are going to do is, so delete cluster, or let's delete everything again, and we would install the things again. So install -f, create -f, and install. Let's wait for the pod to be running, and we would query logs again. So logs. All right, let's create that one resource again. So create -f cluster1.yaml. Okay, and here we go. It says cluster spec. It also got the cluster ID, if you see here. So it simply means that we have successfully made request to DigitalOcean, and we should, here we go, we should see a cluster being created. But if you see here, when we try to update the status of the cluster, we see cannot get resource. So it looks like apart from giving the update permissions on the status, we will also have to give the get permission on that on cluster resources. So API groups, and that's not a problem. I think we are not giving permission to update the cluster resource, but we are just giving the permission to get the cluster resource, and that is because we are doing that as part of the code. So vivek-singh.dev resources is going to be clusters, and verb is going to be just get. So yeah, I think we are good here. I am going to delete everything once again and install everything once again. And I am assuming things should work this time. So get pods, and the reason is we deleted our operator, but we did not delete the cluster resource. So when we redeployed operator, our operator tried to create the cluster again, but we have that cluster already running there. That is the reason this particular thing failed. So we are going to delete all the cluster resources, and once we have deleted that, all right, the pod is running. So logs -f, and now let's go ahead and try to create another cluster resource. So we tried to create cluster 1 again, but it failed because there is a cluster with the same name already being created. Let's go ahead and try to create cluster 2, but we will have to change the version slug, and create -f cluster2.yaml, and this time everything should work as expected. So yeah, we have the cluster ID, we generated the event. So if we get cluster -1, we should get cluster ID, and we are getting the progress as well. So yeah, I think this is how we can package and deploy our operator inside a Kubernetes cluster as a pod. Obviously, as soon as this cluster that is being created gets into running state, the status is going to be changed. The status is going to be changed to running. We are not going to look into that because we have already seen that in one of the previous videos. Uh, yeah, as I said, this is all I wanted to talk about. If you are not very comfortable with RBAC, I already have videos on that. If you are not comfortable with service accounts, I also have videos on service accounts. If you think this is going to be useful to your colleagues, your friends, share it with them. Follow me on Twitter. And yeah, thank you. I am also going to push this entire thing on my GitHub. So yeah, so that you can check that out. The other thing that I wanted to talk about is, so for example, the issue that we faced with version here, the version that we specified in cluster was not available. So to do that, what we can do is, before actually making call to DigitalOcean, we could have validated this particular manifest, and we would make sure that this particular version is available or not. And again, we can do that by querying the DigitalOcean API to fetch all the available versions, and we can make sure that this particular version is available. So yeah, I mean, this is the validation that can be done in our operator itself. So yeah, I think this was pretty much it. Thank you so much for watching, and I'll see you in the next one. Thank you so much.